Hi there, folks. In this lesson, we're going to be looking at graphing the ellipse, which is, again, one of our conic sections. And an ellipse is kind of like an elongated circle. It's a little bit like an oval. More specifically, or more exactly, an ellipse is a set of points such that the sum of the distance between two foci remains constant. In other words, if I think about an ellipse, it's kind of like this elongated circle. And what I have is I have these foci within the ellipse, these two focal points. And when it says that the sum to those remains constant, it means when I measure to the ellipse, in other words, if I measure from here to the ellipse and then to the other focus, if I add up the lengths of those two lines, it's going to be equal to if I do the same thing to any point on here. If I add these two lines together, it would equal the first two lines. Or if I added these two lines together, it would equal the first two lines. Or if I added these two lines together. So as I measure from the focus to the ellipse and back to the other focus, when I add those distances up, I'm going to get the same value every time. That's the true definition of an ellipse. Okay? It's as I measure those distances from the focus to the ellipse to the other focus, I get the same value every time. That's what this is saying. A set of points such that the sum of the distance between two foci is constant. Okay? And then when we talk about the center is just in the middle of all of this stuff. It's the origin or the middle of the ellipse, and that is located right between the two foci, right smack dab in the middle, all right? When we talk about the major axis is the longest diameter of the ellipse. And notice we use the word diameter here, okay? We'll talk about the major axis in terms of diameter and radius when we go to graph this thing. The minor axis is the shortest diameter, okay, of the ellipse. And again, we'll talk about that in terms of diameter and radius when we start to graph this thing. But just like a circle, I measure this thing based on the center and based on the radii and the diameters. The only difference is with a circle, the diameter is the same no matter which direction we go. The radius is the same no matter which direction we go. With an ellipse, I have two different diameters that I really look at. I have a very long diameter and I have a shortest diameter, and it gives me this oblong shape. Okay. For example, when I look at this, and this you need your formula sheet with this. We have that available as well. But when you look at your formula sheet and you look at this thing, there's a couple keys here. When we go to graph this, the first thing we have to do is decide if this is vertical or horizontal. Okay. And typically, we do that based on what value shows up first. Now, in order for this to truly be in standard form, my a value, or my a squared value, has to be bigger than my b squared value. In other words, right here, this denominator has to be bigger than this denominator. Okay? If this thing was written backwards, if this was written as y plus 2 squared over 16 plus the x minus 1 squared over 25 equals 1, that's technically the same equation, but this second thing that I've written here is not truly in standard form because it's written incorrectly. It's written backwards because my first denominator is too small. Okay? My first denominator is associated with the a value, which is associated with the major axis, which has to be larger. Okay? So for this to truly be in standard form, the a value, the first denominator, has to be larger. Okay? So keep that in mind. So now when I look at this thing, this is written in my standard form. X comes first, and that x value is associated with a major axis. So this thing is going to be horizontal. Okay? And really my major axis and the direction of my ellipse are directly tied to one another. Okay? A horizontal ellipse has a major axis that's horizontal. Okay? A vertical ellipse would have a major axis that's vertical. So now I'm just going to identify some of these things. The center up here again is HK, and just like in all of our other type of standard forms or vertex form, it's always the opposite of these things. So when I do the center of this one, it's going to be +1, -2. All right? The foci are listed next, and when we look at the foci on our formula sheet, it'll tell us here that the foci, this is the formula that it gives us, is h plus or minus c comma k. And when you think about that, I know some of these values. I know that h is 1. I know that k is the -2. The thing that's giving me a little bit of difficulty is this c value. Well, the c value, it gives me a formula for that as well. It tells me that c squared equals a squared minus b squared. All right? And keep in mind that my a squared is right here, it's the 25. My b squared is right here, it's the 16. So I'm just plugging these values in, so I get c squared equals a squared, which is the 25, minus b squared, which is the 16. So I get c squared equals 9. And now to solve for c, I take the square root of each side. So I find out that c equals a 3. All right? So what I have here is a 3. Well, this is essentially giving me two ordered pairs. The first ordered pair that it gives me, I would do the 1 plus 3, which gives me a 4. So I have 4, negative 2. And then I would do the 1 minus 3, which gives me a negative 2. So I get negative 2, comma negative 2. These are my two foci. All right? I essentially go from the center. I go one direction to get to one foci, and I'd go the same distance in the other direction to get to my other foci. And that distance that I'm traveling is my c value. All right? The major axis is the diameter of the major axis. And again, that's associated with the a value. If I jump back up here, again, this is my a squared. So my a value here, this is telling me that a would equal a 5 if I take the square root of that. It's just like the same thing we do with our circle in identifying the radius. Well, a is like the radius of the major axis, so the diameter of the major axis would be 10. And it's the same thing here. My b squared is a 16, which means my b value is 4. That's the radius of my minor axis, which means my minor axis, the diameter, is going to be 8. Okay? And now when I go to graph this thing, I'm just going to take this information and I'm going to plot these values. So I've got 1, negative 2, so I do 1, negative 2, which is right here. I plot the foci at 4, negative 2, and at negative 2, negative 2. And then in terms of my major and minor axis, I count it the same way I do my circle. I count the radius, keeping in mind that right here, the radius of my major axis is 5. And since this thing is horizontal, my major axis is also horizontal. So I'm going to count 5 in each direction. So that would give me a point out here when I count 5, and a point back here when I count 5. My minor axis is 8 units long. It's got a radius right here. My b value is the radius of the minor axis, which is 4. My minor axis always runs in the opposite direction of my major. So in other words, I'm going to count up 4 and down 4 to plot this. So just like when I do my circle, I count in every direction that I can. I'm just counting different distances this time because I have two different diameters. And now I draw the best ellipse that I can draw. That is terrible. Let me try again. And there we go. That's a nice looking ellipse. It's got a nice rounded shape, and I did my best. Okay, it's not perfect, but it doesn't have to be perfect. But make sure it looks like an ellipse. Once again, I can't accept things that look like this. That's not an ellipse. All right. So do your best to make it look like an ellipse. All right. If I look at the next one, again, the first key that I have to look for is that my first denominator is larger than my second denominator, which it is, so this is written properly. And so now I look, the y value comes first, so this thing is vertical. I identify the center. The center this time, be careful, I've got y minus k, so my k value is the 3. And again, my k value is always with the y value. My h value is the negative 4. My h value is always with the x value. And that's one of the most common mistakes here when I have a vertical ellipse, is those are written in a different order, so I have to remember which one is h and which one is k. All right? My foci, I have to do this time, I have h comma k plus or minus c. So I need to identify each of these values. It's a negative 4. This is going to be a 3 plus or minus c. I need to find that c value. C squared equals a squared minus b squared, which come right from my denominators, which are a squared and b squared. So I get c squared equals 50. I take the square root of each side. And this is going to give me approximately 7.1. I'm just going to estimate it as a decimal. So when I do that, it gives me two ordered pairs, negative 4 comma 3 plus the 7.1 is a 10.1. And then 3 minus the 7.1 is going to give me a negative 3.1. Sorry, a negative 4.1. Let me try again. And so those are my two foci. Let me write those down, the negative 4 comma 10.1, and the negative 4, comma, negative 4.1. And now the major axis, again, my A value, this is A squared, which means my A value is a 10, which means my diameter here is a 20. Right here, the B squared is 50, which means my B value is approximately 7.1 or 7.05. So then when I double that for the diameter, you could estimate this as a 14.2, or you might estimate it as a 14.1, depending on where you rounded this thing off, okay? It doesn't really matter that much when we go to graph this thing. We're going to be estimating either way. So now I start to plot this, and right away, because of my foci and that first value having a 10.1 in it, I'm going to scale my graph by 2's. So I'm going by 2's here. So when I do negative 4, 3 is going to be right about here when I'm going by 2's. Negative 4, 10.1 is going to be right about here. Negative 4, negative 4.1 is going to be right about here. And now my major axis, since this is vertical, my major axis has a radius of 10. That's my A value, which means I count 10 in each direction from the center. It's going to put me right around here. I count 10 in the other direction from the center. And again, my major axis is vertical because my ellipse is vertical. Okay? My radius, my B value for the minor axis is about 7.1, so I count 7.1 in each direction. We'll be right about there. And now I just draw the best ellipse that I can draw. Okay? I do my best. I make it look as rounded off as I can, and there it is. That's my ellipse. And again, I'm doing a little bit of estimating here, and even my graph when I go to draw the ellipse is a little bit of an estimation. Okay?